Okay, so today we're going to take a look at some more on functions and relations and the differences. Kind of think. I think we got the GeoGebra thing to work. So snag a Chromebook and go ahead and go to the website. Go to Algebra 2 and I'm going to look for polynomial differences. Let's see if I have it here. There it is. Okay, hopefully it works for you. While you're doing that, let's talk about what we did Friday when we were talking about functions versus relations. Okay, what are their differences? How are they alike? That kind of thing. So, first of all, what we said was that a function looks like this, right? So correspondence. Like this. Okay. Or this is the domain, or our input. This is the range, our output. Okay. This is also a relation, because anytime we have a correspondence between two quantities, numbers, we talked about, students versus birthdays. We talked about the Morse code, the GTAP thing, number of different things. Anytime you have some sort of a relationship between two quantities, that's a relation, right? But a function has this one difference, okay? And that is that each element here in the domain is paired with only one element in the range, right? But in this case, we have this function going, this number here, and this number going here. Okay, so we have the number 1 going to two different range values, and that makes this not a function. Okay, so that's the big difference, right? A relation, this is a relation, okay, on this side, this is a relation, this guy, but it's not a function. It is okay, remember we mentioned this, for this to go like this. All right, put another 10 there. Those can all be 10s because we still just have one number in the domain going to one number in the range. But as soon as we have this one number here going to 2, that's where we have a problem. So that's what we talked about. Then we were just getting into this whole idea of polynomial function differences. And we wanted to look at this GeoGebra document for this. So I pulled this up, and here it is. Now here we have a couple sliders. We have a graph, and we have a spreadsheet. Okay, so here's my domain, and here's my range. And I have this x and y sort of relationship, right? That's a function. The C column here represents the differences between these numbers. Notice that it's all 1. Well, no big deal, right? Maybe you would kind of expect that because your graph is pretty linear. Now, if you do a right click on this screen, someplace here, you should be able to get a zoom to fit. Now, I tried it with my pen, and I tried it with my finger, and it does not work. But if I do a right click on the computer, it does work. So when you do it, you'll get a nice diagonal line going through, and you can see that it's fairly linear. Okay. If we change this a value to 2, we notice that it's still linear. It still takes one set of differences to be all constant, but the constant values are 2. So it must be, maybe we can make a prediction, right? What happens if we make this 4, for example? Oh, well, look at that. Or 5. Look at that. Can we try negatives? Look at that. So we can see there's some sort of pattern going on there, okay? We'll move this back to 1. And move this to 2. Now it changes. Again, do a fit to it if you can. Try it. You should be able to, but you might not be able to. We get a curve, okay? And now I notice that my set of differences, they're still different in the first set here. But if I arrow over to my second set of differences, I notice that I all get a constant. And I also notice that there are 2 now and not 1. So what I want you to do is take this GeoGebra document and play with it a little bit. Explore it. Play with the 2's, the n values, and the a values, and see if you can come up with some sort of a pattern. Look at the n's, look at the a's, look at the sets of differences, how many sets of differences, see if you can come up with some ideas. Should take you about 5 minutes, and then we're going to review it. So we'll pause this, you play with it, and we'll come back. Okay, so hopefully you got some ideas. So let's have Ms. Knudsen go ahead and, on the board, write down some ideas that you have relating n and a and sets of differences and so forth. Jot those ideas down, and then we'll go over them and see how close you were. So we'll pause it. Okay, let's see how close you came to the idea. So let's make this back to 1. And this I'll make 2. All right. So this, we know, is a linear. And we know from the previous unit that linear equations have an m here. But the a value on the slider is that coefficient right there. I called it a. All right. So when it was linear, you should have noticed it took one set of differences. Before it became constant. Right? And you also should have noticed that the constant was equal to what number? It was just equal to a. So when we went back here and we made this, a was, we noticed it was 2, 3.5, 5, whatever we wanted it to be. Negatives, we tried that too, we got the same thing, right? Well, that's for when it's linear. What happens when we have a curve? So for example, I did this, right? Now I made the n value, by the way, this is the n value, 2. Well, how many sets of differences did it take that time? You should have said 2 sets of differences before we got that constant. But the constant this time was different, right? So if I make this 2, my constant now becomes 6, which is definitely not 3. And when it was 4, it's 8. So it almost looks like it's twice, right? Interesting. So then we made n3. And how many sets of differences did it take? Well, you should have started saying, oh, okay, I see it now. And the constant? Well, let's see. We had 1a, right? 2a. What do you think? Next one's 3a? Let's find out. Make this 3. Check out the differences. And that constant. Come on, slide over. goes, is moving, inching its way over. 18. Wait a second. That's definitely not 3 times 3, right? So we have something else going on here with that. Not sure. All I know is that it was 18. So I could say, though, that it was 6 times A. But does that work for all the rest of them? Well, let's make A 4. And it does. Last one. You know the answer to that. And the constant. Maybe not quite as easy to see. $48. Wow, that's 24 times. So if we make this 3, yeah, wasn't that something? So it's kind of hard to see this pattern here, okay, on the constant. Definitely we see the differences, right? So the n, or the power, tells me how many sets of differences. But the constant's a little different story. It's kind of hard to see this, all right? But this is called, the pattern here is called a factorial. And it takes the constant is equal to the a value times the n factorial. Well, what is a factorial? N factorial, which is abbreviated with an exclamation point, would be n times n minus 1 times n minus 2. Okay? So, in other words, 4 factorial is equal to 1 times 2 times 3 times 4, which just happens to be 24, which was that number there. Okay? 3 factorial, 1 times 2 times 3, just happened to be 6, which was that. Okay? So, that's how these sets of differences look and work. But I want you to see that these are all functions, and you should be able to tell what kind of a function we're going to have by looking at the sets of differences. Whether it's a linear, whether it's a curve, and we call it the degree of the curve. Okay? So for example, we might say that the degree of a polynomial function is the highest power of the polynomial. So in our case, the polynomial was pretty straightforward, right? I just said they were going to be, well, that's a symbol for functions, but we didn't really do much with that yet, so let's just go y equals. This would be a third degree, because that's the highest power. Okay. 2 was a second degree, and 4th was a 4th degree. So the set of differences tells us what kind of a polynomial degree-wise that it is with powers. That's what that does. So we want you to be able to look at these and decide you're going to get a curve. You might have to zoom to fit them a couple times to see the whole curve, right? Know how many differences it gets. And figure out that, hey, I can find what the constant is by doing that little factorial trick, right? So that was kind of cool. Anyway, so you should be having an assignment to work on. I don't think you'll have any issues with it. Work through it. If we have any questions, we can talk about stuff tomorrow. And I'll see you tomorrow.